Hey everyone, and welcome back to the BioBytes channel. I'm Mick, and in today's video we're getting into some really cool tech that is being developed right now in a lab at UCLA. This is a breakthrough that can genuinely change lives. So, have you ever thought about how you interact with the world? You want to grab a cup of coffee, so your brain and your hand perform a incredibly complex dance of signals and movements without you even thinking about it. Neurons fire from your brain down into your arms, hands, fingers, and just like that, the cup is in your hands. But for individuals with paralysis or neurological conditions, that connection is broken. Well, what if we could build a bridge over that gap? Well, that's exactly what a team of engineers at UCLA has done. They've developed a wearable non-invasive brain-computer interface, or BCI, that uses artificial intelligence as kind of a co-pilot. And before we get ahead of ourselves, no, this isn't about reading your mind per se. It's about inferring your intent and it helping you to complete a task. It's a system that significantly boosts the performance of non-invasive BCIs. So let's get into how it works. The system starts with a cap that records your brain's electrical activity, which you might know as an EEG. EEGs are great because it's completely non-invasive. You just wear the cap. The challenge with this before is that the signals can be noisy and hard to decipher. But this is where the custom-built AI comes in. First, we have sophisticated algorithms, specifically a hybrid model combining convolutional neural networks and a Kalman filter that decodes EEG signals to figure out your movement intention. It's looking for the what you want to do, not just where your eyes are looking. Before we go on to step 2, let's make sure we're on the same page here. A convolutional neural network, or CNN, is a deep learning model that is good at processing and understanding data that is presented in a grid-like structure, things like images or videos. The architecture of a CNN is actually inspired by the human visual cortex. And a Kalman filter is a mathematical algorithm that uses 2 steps, predict and update, to determine the state of something. It uses prediction and measurements to produce an accurate and smooth estimate of what something is or what something's doing at any given time. And second, the decoded intention, so what it's picking up from the brain, is paired with a camera that's watching the scene in real time. The AI co-pilot uses both streams of information, your brain signals and the visual context, to infer your goals and assist you. It's a partnership between human and machine. But the big question, does it actually work? Well, the research published in Nature Medicine Intelligence says yes. In the study, 4 participants, 3 with motor impairments and 1 participant who was paralyzed from the waist down, tested the system. They performed 2 tasks. The first was a simple cursor control task on a screen. With the AI co-pilot assisting, the target hit rate for the paralyzed patient skyrocketed. It was nearly 4 times higher. And the second task was even more insane. It involved using a robotic arm to pick up blocks and move them to a specific spot. This is a task that the paralyzed patient couldn't complete before without the AI's help. But with it, they did it in about 6.5 minutes. All participants completed tasks faster and more accurately with their AI co-pilot. I just really want to hone in on what this means. Current state-of-the-art BCIs often require risky brain surgeries to implant electrodes. They're incredible, but they're still confined to small clinical trials. This new system from UCLA offers a powerful, wearable, and far less invasive alternative. It opens up the possibility for so many more people to benefit from this technology. This technology means that one day, someone with limited mobility can effortlessly control a robotic arm to help them eat, drink, or interact with their environment. That's kind of the goal here, shared autonomy to regain independence. This team, led by Professor Jonathan Cao and doctoral candidate Johannes Lee at UCLA, is already looking ahead. They're working on making the AI co-pilot even smarter, faster, more precise, and able to handle more complex tasks. This research is being funded by the National Institutes of Health and a collaboration between UCLA and Amazon. which is an example of how different sectors can come together and push science forward. When we talk about AI, the conversation often starts to drift towards the abstract or concerning questions about privacy, job displacement, or rearrangements, or really some far-off future that we can't quite or accurately predict. And those are important discussions to have. But I think this is different. This is one of those developments that makes the future of assistive technology rather exciting. It's thoughtful, ethical, grounded in real science, and it does have a direct positive human impact. And considering all the concerns people have with AI, I am still excited to see what this does to help people live better lives. AI helping paralyzed people interact with the world is a very real example of that. In this study, AI isn't like a distant, mysterious algorithm. It's a co-pilot. Its entire purpose is to listen, to learn, and to lend a hand, literally, to someone who needs it. It's not replacing human capacity, it's actually helping to restore it. Scientists are taking powerful technology and channeling it toward a very human goal, granting someone with greater independence and the ability to act with the world on their own terms. This technology can be a force for empathy, for empowerment, and for building a more accessible world for everyone. That's a future I'm excited to see. So, what do you think about the potential for this AI in this capacity? What do you think about the idea of AI co-pilots in general? Let me know what you think in the comments below. Thanks for watching, don't forget to like, subscribe, and I'll see you in the next one.